Hi everybody, our project provides a detailed explanation of ARIMA and seasonal ARIMA and how to do parameter selection on these models. The autoregressive integrated moving average model has one additional parameter compared to the ARIMA model, and is denoted as the ARIMA PDQ model. We learned that difference can be used to make data stationary. However, sometimes a first-order difference may not perfectly achieve stationarity. In such cases, the small d parameter in the ARIMA model represents the number of difference steps required to make the data a stationary series. Let's first take a look at the mathematical definition. Once the d parameter of the model is determined, yt can be expressed as a differential equation at time t and then incorporated into the original model. And then let's use the closed price of Apple from 2019 to 2022 in this experiment. Here we can use ARIMA function, which adjusts the parameters based on the ASA method. If the model's fit is not good, we can also adjust the parameters by observing the ACF and the PACF. And you can see the result here. It's the plot here. In this case, based on ASA and ADF, the program automatically selects the parameters of p equal to 1, d equal to 1, and q equal to 0. The next question is, how do we know if these estimates are correct? So we can use the box-Pierce approach to examine the ARIMA model. This test is performed on the residual series. We know that a good model should have stationary data, meaning that the noise should appear randomly. The null hypothesis of this test is that the residual series is white noise. Therefore, the p-value should be significantly greater than 0.05. Let's take a look at the situation use the box test function. The test tells us that the model is feasible. Generally, at this point, you may not need to continue with further tests. However, if the residual series doesn't pass the test, you will need to use an alternative method, such as analyzing the ACF and PACF to determine the model parameters. And the ARIMA models are also capable of modeling a wide range of seasonal data. A seasonal ARIMA model is formed by including additional seasonal terms in the models we have seen so far. It's written as follows. Seasonal handling is not as simple as just setting the seasonal terms components to true. It involves the use of the Fourier transform as well as the partial autocorrelation coefficients. M represents the seasonality period. For example, in ARIMA 112129, it essentially means that the data has a seasonality of 9, and the later PDQ represents the seasonal part of the ARIMA model. Therefore, the two sets of values may be different. The process is best illustrated via an example. Here we use the sample U retail from FPP library, which are the retail index of Europe by quarter. We can use the ARIMA function to do the work for us, and we can see the result here. The ARIMA functions use NS-diffs to determine the big D, the number of seasonal differences to use, and the N-diffs to determine the small d, the number of ordinary differences to use. And you can see the test. The model's results correspond very well with our expectations and have also passed the box test. And we have discussed both two models, but we haven't talked about order selection. So of course, we have methods like ASA, BISA, and ACF or PACF to help with model order selection, and both methods have their pros and cons. Here is a brief summary that you can consider when using them. However, in fact, both methods are often used together as they excel in different areas. So then, how can we select the parameters in different models? There is a table here. So that's our share. Hopefully we can help you.